Imagine building a magical world with Legos. That's what object-oriented programming, or OOP, feels like. It's a way of writing code that's like creating blueprints for reusable blocks, called objects. Each block has unique properties and actions. Think of a car object. Its properties could be color, model, and speed. Its actions could be starting, stopping, or accelerating. OOP helps us organize code into these neat, reusable objects, making it easier to build complex programs. Why is this so cool? Because it mirrors how we see the world around us. We think in terms of objects. This makes OOP intuitive and powerful. Ready to become a master builder of code? Let's dive into the core concepts of OOP. Every magnificent structure needs a strong foundation. Just like a building relies on its base, our code relies on fundamental principles to stand tall and robust. In object-oriented programming, or OOP, our foundation is built upon four essential pillars: inheritance, polymorphism, encapsulation, and abstraction. These pillars are the bedrock of creating efficient and effective software. These are the fundamental concepts that make OOP so powerful and versatile. First up, inheritance. It's like passing down traits from parents to children, ensuring continuity and consistency. We can create new objects based on existing ones, inheriting their characteristics and adding our own unique twists. This allows for code reuse and extension. Next, polymorphism. This lets objects take on many forms, like a chameleon changing colors to adapt to its environment. The same piece of code can behave differently depending on the object using it, providing flexibility and dynamism. Then there's encapsulation. Think of it as a protective shield around our code, safeguarding it from unintended interference. It bundles data and methods together, keeping things organized and secure, promoting modularity and maintainability. Finally, abstraction. We simplify complex systems by focusing on essential details and hiding unnecessary information, making our code easier to manage and understand. It's like using a TV remote. We don't need to know how it works internally to change channels, just the essential functions. These four pillars work together harmoniously to make our code reusable, flexible, and maintainable, ensuring long-term success. Let's dive deeper and explore each one in more detail, understanding their true potential and application. Let's say we're building a zoo app. Imagine the variety of animals we need to include. We might have different types of animals, like lions, tigers, and bears, each with unique traits and behaviors. Each animal has common characteristics like a name, age, and the ability to eat and sleep. These shared traits can be grouped together. Instead of writing separate code for each animal, we can use inheritance. This allows us to streamline our code. We can create a parent class called animal with the common properties and methods. This parent class serves as a blueprint. Then, we create child classes like lion, tiger, and bear that inherit from the animal class. These child classes can have additional unique features. Let's take a look at some code to see this in action. This will help us understand how inheritance works practically. Python class animal class lion, animal class tiger, animal, Leo equals lion, Leo 5, Leo.eat, mentioned output, Leo is eating, Leo.raw, mentioned output, raw. See how easy that was? By using inheritance, we simplify our code. Inheritance helps us avoid redundant code and create hierarchies of objects, making our code more organized and efficient. This approach not only saves time, but also makes our code base easier to maintain and extend in the future. Remember our animal friends? They all eat, but they might eat differently. Polymorphism lets us define methods, like eat, in the parent class and override them in the child classes to provide specific implementations. Let's see how this works. Python class, lion, animal, Leo equals lion, Leo, 5, Leo.eat. Hash output, Leo is devouring a zebra. Now, even though we're calling the same eat method, Leo the lion eats like a lion, while other animals might eat differently based on their own overridden methods. This flexibility and dynamic behavior is the essence of polymorphism. Section 5. My secrets are safe. Encapsulation explained. Imagine a treasure chest with a lock. Encapsulation is like that lock, protecting the valuable data or treasure inside our objects. It bundles data, known as attributes, and methods that operate on that data within a class, controlling access to them. This ensures that the internal state of an object is shielded from unintended interference and misuse. We use access modifiers like public, which is accessible from anywhere, private, which is accessible only within the class, and protected, which is accessible within the class and its subclasses, to enforce encapsulation. These modifiers help in defining the visibility and accessibility of the class members, thus maintaining a clear boundary. Here's an example in Python to illustrate encapsulation in action. Python class bank account, print my account.get balance. Output 1500. In this example, the mod balance attribute is private. We can't access it directly. We use methods like deposit and get balance to interact with it, ensuring data integrity and security. This way, we can control how the data is modified and accessed, providing a robust structure for our code. Section 6. Simplifying complexity, the power of abstraction. Think of a car. You don't need to know how the engine works to drive it, right? Abstraction lets us do the same with code. We hide complex implementation details and provide simple interfaces to interact with objects. Here's how it works in Python. Python class car. We interact with the car through methods like start and accelerate without worrying about the complexities of the engine. Abstraction makes our code cleaner, easier to understand, and more maintainable. Section 7. Design patterns, blueprints for elegant solutions. Imagine having a collection of architectural blueprints for building different types of houses. Design patterns are like those blueprints for software. They are reusable solutions to common software design problems. Some popular design patterns include singleton. Ensures only one instance of a class exists. Think of a database connection. Factory provides a way to create objects without specifying the exact class. Useful for creating families of related objects. Observer notifies multiple objects about changes in a subject object. Think of a subscribe notification system. Design patterns provide proven solutions, promote code reusability, and make our code more robust and maintainable. Section 8. OOP in the wild real world wonders. OOP is everywhere. From the apps on your phone to the websites you browse, chances are OOP is powering them behind the scenes. Game development. Games heavily rely on OOP to represent game characters, objects, and interactions. Web development frameworks like Django, Python, and Ruby on Rails use OOP principles to build dynamic and interactive websites. Mobile app development, Android development, Java, Kotlin, and iOS development, Swift, embrace OOP for building feature-rich mobile applications. These are just a few examples. OOP's versatility and power make it a cornerstone of modern software development. Section 9. Level up your coding game. Why master OOP? Mastering advanced OOP concepts is like leveling up your coding skills. Here's why it's a game changer. Write better code. OOP helps you write cleaner, more organized, and more maintainable code. Become more efficient. Reusability and modularity save you time and effort in the long run. Tackle complex projects. OOP equips you to handle large, complex software projects with confidence. Boost your career. OOP skills are highly sought after in the software industry. By embracing OOP, you'll become a more versatile and effective programmer. Section 10. Keep exploring. The journey continues. Congratulations on reaching this milestone. You've embarked on an exciting journey into the world of advanced OOP concepts. Remember, learning is an ongoing process. Keep experimenting, keep building, and keep exploring the endless possibilities of OP. As you gain more experience, you'll discover even more powerful techniques and patterns that will elevate your coding skills to new heights. Keep pushing forward, and happy coding.